So the first graph we made was for f of x equals 2 to the x. What I'd like to do is do a kind of sister function to that. So let's look at h of x. Let's look at 1/2 raised to the x. So in particular here, right, this is a b value that's less than 1. So I want a base value that's less than 1. There's going to be a lot of stuff that's similar here to the graph that we just did. Obviously, in some sense, 1/2 and 2 are very closely related base values, sort of 2 being our real number that we're working with here more than anything else. But I guess also, obviously, having it be 1/2 instead of positive 2, right, 2 over 1, is clearly going to have an impact. Let's try to essentially just make the same table that we just did. So x's and y's. So 3, 2, 1, 0, and then -1, -2, -3. Let's put all those in. Let's just crunch it, just throw the numbers in. Let's just kind of see what we get as a result. We'll kind of keep that 2 to the x graph in our mind as we go. And we can kind of redraw it maybe as a reference in the end. So let's see. So h of positive 3, so this is going to be 1/2 raised to the 3. So x is 3. So we're going to cube this. What that means is a couple different things. You can either write it as, right, I guess the most obvious thing is 1/2 times 1/2 times 1/2, or you can write it as 1 cubed over 2 cubed. Either of these things work, and they both get us to the same value, which is going to be 1 over 8. So what's happening to us here, right, is if we raise a fraction value, right, a value that's less than 1, if we start raising it to a higher power, we're going to get smaller numbers out of it, right? You're doing 1/2 of 1/2 of 1/2, right? 1/2 times 1/2 times 1/2. So every time you multiply by 1/2, you're literally cutting your number in half, right? You're making it smaller, and that's obviously going to have an impact. If we do x equals 2, 1/2 squared, right? So that's going to be for us 1 squared over 2 squared. That's going to be 1/4, 1/2 of 1/2. If we do raised to the 1, anything raised to the 1 is going to be itself. So 1/2 raised to the 1 is going to be 1/2. That kind of fits into our pattern, right? 1/8, 1/4, 1/2. This makes sense. Once we hit 0, we said anything raised to the 0 is going to be 1. So that's going to be true here, because if anything raised to the 0 is 1, 1/2 is anything. 1/2 is a thing. So that's going to be raised to the 0 is also going to give us a 1. If you think back to our 2 to the x graph, these are the same kind of y values we were getting, but we were getting these values when we had the negative exponents rather than the positives. So we're getting very similar numbers, but we're getting them in a little bit of a different order. This is to be expected. This is what happens. If we start to put negative powers into here, so if I do -1, so what happens here, right, is if I do anything raised to the -1, the idea is that you're saying 1 over that value, you're sort of doing a reciprocal, and then you're raising it to the positive version. So if I am starting with a fraction, right, 1/2 to the -1, that's really going to be just the reciprocal, 2 over 1 to the positive 1, which is just going to get me a positive 2. So 1/2 raised to the -1, what you're doing is you're doing a reciprocal, so the 1/2 gets flipped, and then you raise it to the power, in this case just positive 1. You can imagine what's going to happen then is these negative exponents get a little bit bigger. Right, if I do -2 or -3, so now it gets flipped, 2 over 1, but it's squared. Well, 2 over 1 squared, 2 times 2 is positive 4. And then last but not least, right, -3 I'm going to take this 1/2 and we're going to flip it and cube it. So 2 over 1 cubed is 2 cubed is 8. So we're getting very, very, very similar coordinates to what we did for 2 over 2 raised to the x. But the roles of the positive and the negative values have flipped. This is going to give us a kind of left-right symmetry between these two graphs. Neither of these graphs themselves are symmetric, but they have a type of a symmetric relationship. They have kind of a complementary relationship where they're doing similar things. They have a similar curve, but sort of going in opposite directions. Let me graph this 1/2 to the x, and then maybe we'll sort of redraw our 2 to the x on the same graph to sort of show the relationship between them. So we said 1, 2, 3, 4. So what are our coordinates? I kind of like doing, again, our exponentials starting at the center. It's usually a good idea to go left to right, but I like having that 0, 1 coordinate as sort of a reference point, as like a starting point. So that's going to be there. If I do, let's do these negative values first because they're going to be a little bit easier to graph. So -1 is up to positive 2, -2 is up to positive 4, and then this -3, 8, right, is going to be kind of, somewhere up in there. The positives gave us things like 1/2, 1/4, 1/8, really tough to sort of draw in here nicely without zooming in a little bit further. So we're getting this similar kind of shape. We're going, in this case, the only difference is we're going sort of up and to the left, and then the leveling off process is happening as we move to the right. So we've got this asymptote at y equals 0. As we move to the right, we have this sort of increasing and sort of rising up to positive infinity relatively quickly, right? Getting pretty steep pretty fast. In this case, moving to the left. So that was, right, h of x 1/2 raised to the x. If I redraw that 2 to the x graph, we'll sort of do our points from memory, right? But it was the same kind of shape. It's just coming from the other direction. So it was positive values on the right, and then our smaller fraction values, 1/2, 1/4, 1/8, on the left. With that, right, 0, 1 in the middle as a common point. So our f of x, which was 2 to the x, right, has this kind of a look. So this was our asymptote at y equals 0 as we move to the left instead. So these two graphs, right, they have a symmetry between them. Again, neither of them individually has symmetry, but the relationship is a symmetric relationship if we compare these graphs to each other. In general, this is going to be true for any kind of, right, whole number base versus a reciprocal sort of fraction version of the same base. If you compared 3 to the x to 1/3 to the x, right, 10 to the x versus 1/10 to the x, and so on and so forth, you're going to get this kind of mirror image back and forth. If we just sort of say in general, I'll sort of mark this down on the bottom. Right, if our b value is greater than 1, f of x equals b to the x. So it's going to go through 0, 1, and it's going to be up and to the right. It's going to go something like this, right? If our b value is between 0 and 1, then our exponential graph instead right, it's still going to go through that 0, 1, but it's going to drop to the right, and it's going to rise to the left. The bigger the b value, right, 10, 20, 30, right, the steeper the graph is going to get. Same kind of thing with the fraction values, right? If your sort of number on the bottom, I guess you could say the smaller the b value, right? 1/10 versus 1/100th versus 1/1000th. You know, obviously as you get down to those values, the graph gets incredibly steep very, very quickly. You'd need to really zoom in to even start to see some of these curved things. It would almost look like a vertical line, depending on how you were graphing it. So that's the relationship between these two. That's sort of very generically what these graphs are going to look like. There you go.